right, we're ready to get started. We'll at least get the intros done on this in the very first section. It's important. We need to go ahead and get that taken care of. This is our last major module for the semester. There's one other after this, and it's called decontamination. It's not going to be real involved, but there are some specific learning outcomes that we'll have to make sure that we get to. It'll kind of be a little bit of a relief or a reprise from the regulations, because they're really not specific regulations dealing on decontamination. So what we're going to be talking there are more technique and processes that are used in the decontamination effort. But to get there, we've got to finish transportation, and this is a very major portion. We talked, the very first thing we did was a little intro to regulations and kind of laid a big general framework for it. And then we talked about control, use, and storage of radioactive material in a generic, general sense of control and what the regulations require. And then this last section, the one we just finished the exam on, dealt specifically with rad waste. This, transportation, is really applicable to all of it. And as you saw in the control, use, and storage one, we touched on that just a little bit when we looked at the receipt requirements, your responsibility as far as the surveys that are needed and the requirements that are placed on them. And we're going to hit that again here, because it is part of the transportation requirements that have to be satisfied as well. So you'll kind of get a review of that as we get to it. The transportation learning outcomes, and you've already learned a little bit about some of the learning outcomes. They can not have a whole lot of words to it, but there's a whole lot of material involved. Well, here you go. Identify regulations and procedures for shipping and receiving radioactive materials. That could be as big as it needed to be or small as it needed to be, and we're going to kind of split some of that out and cover it in other sections. But in order to understand a lot of what we're going to do, we're going to need to get a vocabulary going as far as radioactive transportation is concerned, and that's where these definitions come in. A lot of terminology involved, and we're going to hit all of them that's needed, but they will at a minimum include these. And you can see type A and B. That is not the waste classifications for 10 CFR 61. It's something totally different. Although it's related. Interesting. Low specific activity. A lot of these names may give you some indication of what they mean. Radioactive white 1, yellow 2, and yellow 3 labels. Specific labels used at specific times. We're going to talk about that. Highway route control quantity, limited quantities, exempt quantities, special form and normal form. And then the regulatory limits for rad levels and contamination levels. Again, we kind of touched on that when we talked about receiving radioactive shipments or receiving radioactive material. And we'll hit this again from a 49 CFR standpoint. Look at the different methods that can be used for determining radionuclide contents of a package. As you'll see, the transportation and the labeling and the controls and the packaging and really everything is bedrocked on isotopic identification and quantifying that isotope in a shipment. And so there are specific regulations that tell us how to come up with that number. And you'll see how we're going to do that. Radiation contamination surveys on packages, state and applicable limits. That's kind of a repeat of that previous one. Describe necessary radiation contamination surveys to perform exclusive use vehicles. You'll recall that was a key identifier of whether it was exclusive use vehicle shipment or non-exclusive use. We're going to explore that again. And then also we're going to look at the proper placement of the placards on the transport vehicle. There's a thing in the regulations that is called hazardous materials communications. Placarding is one. And placarding has to do with the markings that go on the side of a trailer. You've seen them moving down the highway. You know, it'll say radioactive, has yellow, and the tray foil. That's a placard. And there's specific placards that must be in place at specific locations on that transport vehicle in order for it to move down the highway. And we're going to talk about what those are. This is, again, we've covered procedures for receipt of shipment and some of the actions that are required. We're going to review that as part of this lesson. The outline, we're going to start with regulations, and ultimately we're going to wind up really digging deep into one of them, and that's 49 CFR. Terminology, have quite a few terms I need to get over. And then packaging, radioactive material packaging. Very important concept. And it starts with what is a package. And there is a regulatory definition for that. Transport controls, what controls are put into effect for the actual transport of the material, in accordance with the 49 CFR. The LSA and SCO shipments, low specific activity, and surface contaminated objects. That's what this acronym stands for. We'll define that in more detail later. But we're going to look specifically at those two types of shipments because they're the majority of the shipments that we do. And we'll dig deep on that. Then this thing I referred to there a while ago, hazardous material communications. All the different things that go into communicating the hazards associated with the material that's being transported. Real quick blurb on quality assurance as far as the container and packaging, things like that, how to ensure that the packages that you're using meet the requirements as far as the manufacturing requirements for use to do what you want to do. It's a pretty straightforward section. And then all of this pretty much is going to be 49 CFR, but we are going to step back just a little bit and take a look at the NRC regulations pertaining to transportation. And there are some specific ones. 10 CFR 71 specifically, and then 10 CFR 20 has a few little things in it that you've already discussed. We'll just refresh those. And then there's a kind of a catch-all at the end to pick up the miscellaneous. Any questions on the direction we're going? We've got like 3 class sessions for this, I think, which should be plenty to get it done. But we'll use the time, I promise. So let's start with regulations. The regulations. Some of this we may have already touched on previously, but we'll zip through it. They control the transport. They were initially initiated through the Postal Service. That was the original regulations regarding transportation of radioactive material. But over the years, the Interstate Commerce Commission got involved. And today, there are actually 5 groups that have some level of regulation over transportation of radioactive material. And you can see them listed here: DOT, NRC, Postal Service, individual states, and now the Transportation Security Administration, or the TSA, has responsibility. DOT and NRC are the primary ones. TSA certainly has authority, but it's mainly geared toward the Homeland Defense aspect of it, and we're not really going to get into that because what it does is it dovetails onto the DOT regulations and basically acts as an enforcement arm for the DOT. NRC and DOT do share common responsibilities, and so that they don't step on each other's toes and don't wind up with inconsistency between the regulations. They do have a memorandum of understanding between the 2 agencies to kind of prescribe who does what. This belongs to you, and this belongs to me, and I won't tread in your territory, and you won't tread in my territory, just so that there's no confusion there. You can see DOT 49 CFR, that's the reg, and we're going to spend a lot of time on it. It's called transportation. It has several parts. The parts specific to radioactive material are 170, it says 189 through 189, but, and there are regulations on out there, but 170 probably to 178, I think is where most of it is. You'll have access to these links. I think I've posted this section of it already on Blackboard, so you can kind of get to the regulation itself. And then NRC 10 CFR 71, which is called packaging and transportation of radioactive material. 49 CFR, as I said, is the one we're going to spend most of our time on, because that really has the nitty-gritty of it. 10 CFR 71 kind of deals with special packaging. And we will look at it, but not in as great a detail. 49, more detailed, all aspects of transportation. The packaging, very important, and you'll see that when we get to talking about the different types. Shipper and carrier responsibilities. Who is responsible for what in regards to that radioactive material that's moving across the highway? And there are specific responsibilities that are delineated in the regulations that must be adhered to for each of those. Specific documentation. It talks in great detail about shipping papers. And you'll experience this as you move through your career. Not just anybody can be qualified a RAD waste shipper. You may be assigned to the RAD waste group as an RP technician, but there are specific responsibilities that that organization takes on as a shipper of radioactive material that's only entrusted to people who have had specialized training. And there are courses they pay, I don't know, $2,000, $2,500 to send folks to specialized training so that they get what you're going to get here and about 3 or 4 levels deeper, and actually learn how to run the, most of it's computerized. There's a computer program that generates it for you, but you have to put it in, and you have to know what you're putting in. But there's the software is addressed in the training, and some of the little finer tune points of applying it to the shipping papers. But it is delineated in the regs. And it deals with all levels of radioactive material. And you can see from exempt quantities, and there is a classification called an exempt quantity. And I'll talk about that. And then there's this ultra high, very high level of radioactive activity that's dealt with, and it covers all of it. Has regulations for all of it. As I said earlier, 10 CFR 71 is primarily concerned with special packaging requirements for the higher level quantities. And we will touch on that toward the end. NCFR 71 basically relegates the authority over to the DOT when the NRC regulations are not applicable. So we're going to stick with the DOT. The Department of Transportation regulations that deal with radioactive, or really any hazardous material, is referred to as Hazardous Materials Regulations, or HMR. You'll see that acronym used a lot. Hazardous Materials Regulations. And it's an umbrella term that's used to apply to the entire area of hazardous materials, of which radioactive material is only a part. I mean, we're talking about explosives, liquids, solids, chemicals. You see them moving down the highway all the time on these trucks. You know, the liquid nitrogen, cylinder tanks, truckers, the bulk carriers for gasoline or oil. They all have DOT placards on them. But it's all some level of hazardous material. And HMR is that umbrella term that refers to the regulations that deal with all of it. It applies to transport by interstate, intrastate, foreign carriers, by rail, car, aircraft, motor vehicle, and waterway vessels. It also deals with shippers' pre-transportation activities. What do you do beforehand as far as getting that material and that package, that shipment ready to put it into the highway system, or rail car, or aircraft, or wherever. It also deals with the marking, labeling, and placarding, as well as the shipping papers. So HMR covers all of that. It also catches manufacturing, fabrication, and marking, maintenance, reconditioning, repairing, or testing of the packages or containers that are used to satisfy the HMRs. Okay? So if I'm using a DOT 7A drum, that has significance. A DOT 7A drum meets certain manufacturing requirements that have been stipulated through the HMR. And as long as I maintain what I put in it in accordance with the design specs, then I'm good. But HMR covers all of the manufacturing, reconditioning, marking, maintenance, the whole 9 yards associated with packages or containers. Now, as I said, HMR covers everything. There's 9 classes. Radioactive material is class 7. That's where we deal. That's where we're going to talk about. If you are interested, you can go to one of the links I provided you there, and you can see how it classifies it out as far as the other 8 classifications. But we are class 7. Radioactive materials is class 7. Did I say radioactive materials was class 7? Okay. I just wanted to make sure.
It's important to know. And that's testable material, I think?
Yeah.
Something like B.
Now, some of the sections of the HMR that are specific to radioactive material, and this is not all of them, but you can see, I just want to put it up because it illustrates. 173 deals with class 7 materials. 174 deals with requirements for class 7 materials, detailed requirements. 175 deals with specific regulations according to applicable to the classification. How do you classify the material? Again, 176, more detailed requirements. 177 talks about class 7 again. And you can see it sounds repetitive, and it is to a certain extent, but it's just different aspects of the same dealing with class 7 waste. So that's an introduction to the regulations and kind of sets the stage for getting into the terminology. Which class is it?
Class 7.
This one. Class 7. Terminology. Now, up to this point, we've had a lot of definitions thrown at you. I know that. And we've even given you definitions of what a radioactive material is. There is a DOT definition of what radioactive material is. And it doesn't necessarily match what you may think radioactive material is, because it's a DOT definition. And here it is. Radioactive material, in accordance with DOT, is defined by radionuclide specific values versus a single value. And by that I mean this. At one time, there was a 70, I'm getting my units mixed up. It's a millibecquerel, I think, per gram limit. If it were more specific activity, 70 millibecquerel per gram, it was radioactive material. They did away with that. It's not just one number now. It's radionuclide specific. And so it's critically important that you know what you've got in your shipment, what radionuclides are present. And if you go to 49 CFR 173 here, is that it? Nope. There we go. 49 CFR 173-436. Now, I know you can't read this, but I just want to show you the table. It is a table, and it lists all commonly used or transported radionuclides. That would be here. It gives you the element and atomic number for it. And what this is it lists out the activity concentration or the specific activity, right? Concentration per, or activity per gram. And it's in becquerel per gram or curie per gram. Now, there is a note associated with the units. And I encourage you on these tables, get used to going to the bottom and reading what the notes say. Because there's useful information in the notes to help you use the table properly. But the note that applies to this basically tells you that the standard units, the curies per gram and curie, those are not necessarily accurate. They're there for information or information purposes. These are the exact numbers. In other words, they may have done some rounding on these standard unit ones that might impact the answer. So the more precise value is in the SI columns. But you can see, like the activity concentration for actinium-225 is 1 times 10 to the first becquerel per gram. Becquerel per gram. Now the question comes up: what if you have more than one isotope? All right, let's do this. Let's think in this term. Remember when we talked about the secular equilibrium? Do you remember the isotope that we used? That was a beta emitter, strontium-90, and its daughter yttrium. And we showed how yttrium will keep being produced, and ultimately it'll reach up to an equilibrium that looks like it never decays. But what it is the parent half-life is so much longer, it just sits there and it replaces whatever yttrium's decaying. And so it looks like yttrium's got a really long half-life. In reality, it doesn't. Well, we would want to know about that relationship, right? If we're using this table to determine whether something's radioactive or not. Well, they did us a favor. The values here include the daughter products for secular equilibrium. So when you pick the value here, that includes the value contributed by the daughter, as long as there's a footnote. If there's an absence of a footnote, then you've got to calculate it. And there's even regulations to tell you how to calculate it. And I'll show you that in a second. So that's just, that is where we go to and it's called exempt material activity concentrations and exempt consignment activity limits for radionuclides.
It's just one daughter product, right?
I'm sorry?
It includes just the immediate daughter product?
Yeah. For secular equilibrium situations.
They're going to be one.
Okay, so radioactive material is defined on a radionuclide specific level. That's one thing that you need to know. Well, you may or may not have noticed there, but it also talked about consignments. It gives us a total threshold or threshold value for the total activity in a consignment. A consignment is a shipment that has more than one package in it that's radioactive. So I've got to determine radioactivity based on a per package basis. Or I can determine radioactivity based on the entire shipment. And that's the consignment out here. Now, which one do you use? You use them both. Regulations tell you that it has to satisfy both levels. It gives you a level per radionuclide and a level per consignment. And to be considered a radioactive material under the HMR, remember, this is the DOT regulation definition, the material must exceed both the nuclide specific exemption and the consignment exemption. So you got to look at both of them. Look at the individual radionuclide. Does it meet the requirement of radioactive material? Yes. The whole package with all the isotopes in it, does it meet the consignment level? Yes. Okay. Then it's radioactive. Look at the individual radionuclides. Oops, I've got some that don't meet the definition. Then it doesn't matter about the consignment. If I'm not meeting the specific one, then the shipment as a whole is not considered radioactive material. That's DOT regulation. It's got to exceed both to be considered a radioactive material shipment. That does not say that it's not handled as radioactive material. Okay? That's not what it's saying at all. It's saying under the hazardous material regulations, it is not treated as radioactive material. That's hard to get a hold of, hard to accept, but that's what it says. Now, does that happen very often? No. And you still, if you've got a combination of radioisotopes, you still there is still a procedure that you go through, and you basically do some of the fractions to determine whether it's radioactive or not. This gives us the little thing about the secular equilibrium. If the footnote is present, only activity of the parent needs to be compared to the example to determine if it's radioactive material for shipment. If no footnote is present, then you go to this section and it provides very simple explanation on how to come up with the value. And in essence, it's the sum of fractions. How much activity is there? How much was the limit? Take that fraction for that isotope. How much is there? How much was the limit for isotope P? Plus how much is there divided by the limit for isotope C? And then you add them all up. Everybody with me on sum of fractions? You understand what I'm saying? Okay. So that's the DOT radioactive material. DOT radioactive material for the purposes of shipping under the hazardous material regulations. That's your first term. Questions? Let's look then at the next term, and that is special form radioactive material. Special form radioactive material. And you really are already familiar with this. I just don't know that you've ever heard it called this. For DOT purposes, special form radioactive material are those materials which, if released from a package, would present a hazard due to direct radiation only. All right, due to external radiation only. Usually, because of the physical integrity of the material itself, contamination is not expected normally, even under severe accident conditions. There is a restriction on the dimensions for a special form. It must have at least one external physical dimension that's greater than 5 millimeters. It's got to be at least 5 millimeters, 0.197 inches, not very big, but it has to have at least one physical dimension that big or bigger. Special form encapsulations are required to be constructed in a manner that they can only be opened by destroying the capsule. Only be opened by destroying the capsule. In other words, you can't take it apart, get the radioactive material out, put it back together, and it not be detected. So what does this describe to you?
A little of this.
Huh?
The ones just we use in the labs.
Okay, kinda, yeah.
It starts with a V.
Starts with who?
V.
Vitrification? That's probably too big.
Okay.
Yeah, that might be considered those special form for purposes of transportation.
Radiography stuff,
Hmm?
like your radiography.
Uh-huh. Yeah, radiography source. And that's exactly what it's geared toward. Those types of highly radioactive, encapsulated radioactive material that has, pretty high physical integrity. You're not just going to, you can't step on it and smash it. You can't even run over it and smash it, really. Except maybe with a train. But here's some examples. That's a neutron source disassembled the housing, but these are the internal housings. And what they would do is put the radioactive material within, and then these caps are welded on. And so the only way to get them off is destroy them. An industrial radiography source, sterilizer process, radiator source. That whole piece there would be. Here's the industrial radiography source that we're most common. And this would be the, this is the source end. It's totally sealed. That is special form radioactive material. So anytime you see the HMR referring to special form, this ought to come up in your mind as the type of radioactive material that they're talking about. And on the other hand, normal form, this is really easy. It doesn't get any simpler than this. If it's not special form, it's normal form. Basically what I say. If it does not qualify as a special form and it's radioactive material, then it's normal form. Some examples, you can see them listed there. Liquid inside of a bottle that's inside a metal container, dry paper inside a plastic bag, powder in a hard container, compressed gas bottle, compressed radioactive gas. And this just graphic illustrates it. So normal form is everything else. Any questions on special form versus normal form? Now, that becomes really important when we start talking about these terms. Because these terms, A1 and A2 quantity limits, these terms are keyed, they're tied to special form and normal form. And they are quantities that are used to determine such things as the type of packaging for a specific type or a particular type of radioactive material shipment. This is how we determine the packaging that is required for material that's going to be shipped. It's A1, A2 value. Each radionuclide is assigned an A1 and an A2 value. A1 applies to special form. So if you hear an A1, that by definition, that's special form radioactive material, period. A2 applies to normal form. Now, you would expect A1 in most cases to be higher, a higher quantity than what you see in the A2. And that's indeed the way it is, typically. But by definition, A1 is the maximum activity of a special form radioactive material that is permitted to be in a package called a Type A package. A1 is the maximum activity of special form radioactive material that is allowed to be in a package classified as a Type A package. And likewise, A2 would be the maximum activity of normal form radioactive material that is allowed to be in a Type A package. So this really is the second tool in classifying waste, or classifying radioactive material under HMR. First one was normal form, special form. Well, actually, it's the third one. Is it radioactive material according to HMR? That's the first one. Then, is it special form, normal form? Then, what about my A1, A2 values? If it's special form, I'm going to look at A1. If it's normal form, I'm going to look at A2s. And those values are the maximum activity that's allowed in a type A package. We'll talk about types of packaging later. But those are the steps leading up to in classifying radioactive material shipment. Now, I've taken the actual table and, oops, wait a minute, I'm not finished. Went back. Oh, there we go. I've taken the actual table and just picked out some to give you an idea of the relative values that you're looking at. Carbon 14, you can see 1100 versus 81 for special form versus normal form. Likewise. Now, all of them pretty well until you start getting down here to cobalt 60, and it really doesn't matter. 11 curies is A1 and A2 value. Questions on A1, A2 values? And I think here's the table for A1, A2. See the type of information that's provided. And again, A1, A1 in SI units and standard units. And the same note applies. The more accurate number is in the SI. And then the A2 for both systems of measurement. And then over here you have specific activity, which has a note that applies that we're not going to talk about. That's where you get your A1, A2 values. Exempted quantities, that's the next term. Exempted quantities.
Accepted or exempted?
Accepted, I'm sorry, accepted. Thank you. That's important. Accepted quantities. And that is the correct term. If a small fraction of the A1 or A2 is being shipped, some shipments can be accepted from some of the requirements of HMR. And they can be shipped in what is called an accepted package. And again, we're going to talk packaging as a separate unit, and we'll talk about what an accepted package is. And here's the types of materials that you're looking at that you may apply accepted quantities to. This thing called limited quantity, if you go to that link, it gives you the specific radioisotopic quantities. Radioactive instruments or articles. This one includes things like smoke detectors, relatively low radiological impact, radiological dose rates and contamination levels extremely low, and really no direct hazard. However, they are still radioactive material and have to have some level of control, so they're shipped as an accepted quantity in an accepted package with specific requirements. Same thing here, articles manufactured from natural or depleted uranium or natural thorium, and then empty packaging. And, we don't really think about empty packaging, but once a package has been used and the radioactive material contents have been removed from it, if it has any residual radioactive material in it, then it now is radioactive and can still be shipped, but chances are it's very low residual, and so it can be shipped as an accepted package or an accepted quantity. Each one of those links takes you to a section of the reg that talks specifically about that type of material. Accepted quantities. That's on the very low end. Okay? Very low hazard, not much involved with it. On the other end is this thing called highway route control quantities. HRCQ. It deals a little bit more with more substantially hazardous from a radioactivity standpoint. Quantity of material within a single package, important, within a single package which exceeds 3,000 times either the A1 or the A2 value, doesn't matter which form, 3,000 times that value, or 1,000 terabecquerel or 27,000 curies, whichever is less. Now, the title would kind of lead you to believe that it's restricted to those things transported over the highway. That's not true. It can be transported via any mode of transportation. And so you can have a highway route control quantity going rail, or a highway route control quantity going by ship, or by air, probably not by aircraft because it's too high. But all modes of transport, not just highway. And if a single package exceeds or contains a quantity in excess, it is a highway route control quantity regardless of the mode. Even if it's more than the definition, it is still a highway route control. Any questions on that? That's the higher end. We're just talking about definitions now. We'll get to talking about packaging and actual communication requirements later. Okay, I've got two more I want to talk about, and we will be finished. I've already introduced it when we talked about it, the outline. We said we're going to talk about LSA and SCO. Well, let's define it. LSA means low specific activity material. Low specific activity material. And as you might suspect, the definition is radioactive material that has a low activity per unit mass, or low specific activity. Most of the LSA limited radiation hazard because of low concentration. That would be a characteristic of an LSA. And basically it's just telling you the specific activity divided by the mass of the material in which the radioactivity is distributed. Now, where that gets in is if we had, say, a very high activity source that we were getting ready to dispose of, and they do. Cobalt-60 has a relatively short half-life, and the sources sometimes have to be replaced before they've decayed off. They're just not useful. If you need a 5 curie source for a diagnostic treatment and it's down to 2 curies, it may not be useful anymore. Still highly radioactive. Would have to be disposed of. And what you can do is, you may think, well, I'll take that high activity and I'll put it in this huge big old container of low activity stuff, and if I take the mass as a whole, I'll be able to say, hey, it's low specific activity, because I'm taking the volume of that great big shipment, and I'm diluting basically, or trying to dilute it. You can't do that, because you have that one, you've got to go with the activity of that one. So that's what it says. Activity is divided by the mass material in which the radioactivity is distributed. mass of the packaging that may surround the LSA is excluded from the calculation. So that big volume of low-level stuff I can't use in my calculating my LSA, my specific activity. So that's just a restriction, so that it's kind of one of those closing the loophole things. Now, LSA itself is split into 3 levels. LSA 1, 2, and 3. LSA 1 being the lowest specific activity, the less radiological hazard. Generally consists of unirradiated natural depleted uranium, thorium compounds, processing ores, other nuclides with an unlimited A2 value. And A2 applies to which form? Normal form, that's right. Material with a specific activity not exceeding 30 times the exact concentration. And concentration is such that a person cannot physically breathe or ingest enough to give significant exposures. Very low level. Now, in case you're wondering, I'm not going to ask you to define the different levels of LSA 1, 2, and 3. Define LSA. This is to give you some insight into that definition. LSA 2, you can see it gets down to the activities for solids and gases, for liquids, must be distributed throughout the entire material, and it talks specifically about water with tritium. The limit is 0.8 terabecquerel. And then LSA 3 consists of solids in which the material, let's make that differentiation. LSA 2 can have solids, gases, and liquids. But you get over to LSA 3, it's solids, no liquids or gases. Distributed, uniformly distributed in a binding agent. Remember when we talked about solidification, where we mix concrete in with it, that's what it's talking about. The activity would be within this monolith that has been formed by concrete. Relatively insoluble, can't have a leach rate. You don't have to worry about that. It's just, but that is one of the design considerations coming in for LSA 3. It's got to be as part of the design specifications for the process of solidification that was used. So that's the 3 levels. There's one last requirement on LSA, and it's a limit on the total quantity in a single package. You got to limit the quantity of an LSA material in a single package so that the external dose rate from the unshielded material does not exceed 1 gram per hour at 3 meters from the unshielded material. That's a max dose rate permitted on LSA. That you probably would want to know. Which is the equivalent of 10 millisieverts per hour. Now, I will point out that in the definitions we talked about things like distributed throughout and essentially uniformly distributed and all of that. There are definitions for those terms. Not definitions you need to know. I just want you to know that they're very prescriptive in what that means. And you can go to the regs yourself and take a look if you're interested. That's LSA. This next one's surface contaminated objects. What this does is this gets those things, so far we're talking about things that have as part of their inherent nature radioactivity. Okay? They're radioactive. This captures those things that are not radioactive, but they've been contaminated. And they have radioactive material on them or in them. So as you might suspect, It deals with loose surface or non-fixed contamination. The object itself is not radioactive, but has radioactive material distributed on its surfaces rather than distributed within the material as for the LSA. That's not to say it can't have internal contamination. It can. It's just saying it's not mixed in with the material itself. There are two categories, SCO1 and SCO2, and it is split down. You've got, and I only listed the standard units. When you look to the reg, it lists SI as well, and it also gives you D per M per centimeter square. But I've just listed microcuries per centimeter square. It's split down on accessible surfaces, the outside of it. Non-fixed includes most alphas. Then non-fixed beta gamma and low toxicity. And if you were wondering what low toxicity is, here you go. There's your definition. It's low level natural uranium, depleted uranium, natural thorium, uranium-235, 238, or 232. There you go. That's the definition of low toxicity, alpha. So that's non-fixed, but there's also fixed. And you can see for SCO1 and SCO2. Same information as far as averaging it over 300 centimeters squared. If you'll recall that when we talked about this previously in receiving radioactive material. It is basically the same information. And then there's inaccessible areas. This is internal surfaces, or areas where you can't get to, but you know it's contaminated in there. Fixed plus non-fixed. You'll notice that they combine the two. And that's probably because you can't actually get a good direct frisk and a smear survey of internal surfaces. Same footnotes apply. And here are some observations about the two categories in relation. The SCO2 limits exceed the 1 limits by a factor of 20. Okay, so SCO2 is higher by a factor of 20, except on the non-fixed, on the accessible surface. And you'll see that it exceeds it by a factor of 100 in that case. For both SCO1 and 2, the beta gamma and low toxicity alpha limits are a factor of 10 greater than the limits for the other alpha. And on the inaccessible surfaces, the total fixed plus non-fixed, the same as the fixed on the accessible surface for both 1 and 2. You don't have to remember those, that's just observations about the limits. And here is remember we had a radiation limit? Here's an SCO limit in a single package. It's got to be restricted so the external radiation levels for the unshielded material does not exceed 1 rem per hour at 3 meters from the unshielded material. Same thing, right? So regardless if you're talking about radioactivity because it is radioactive material or radioactivity because it's contaminated, you have this same limit placement for a single package. And just like we had distinct definitions for uniformly distributed and such, there's distinct definitions for the terms used in this, concentration, non-fixed, accessible surface, all that's defined in the regs. Because you've got to know what the regs mean when they define those terms, you being the licensee or the shipper, because you have to put in place procedures that ensure that you meet those. And so your procedures will be written such that directions are given so that you can show that those definitions are met. as far as accessible or inaccessible surfaces. Really, there's two slides left. That's LSA and SEO. There is this last category called fissile. And it is material that has the capability of undergoing nuclear fission and has the probability or possibility, potential, to produce a criticality event, which would result in the release of significant radiation. And because that's such a special material, there are specific requirements for shipping it. And there's also specific requirements for the package design so that you don't get a critical mass in one place at one time. There are limits on the mass that's permitted in any one shipment of any specific isotope to ensure that you do not hit that critical mass. Fissile material is defined as plutonium-239, 241, uranium-233, uranium-235, or any combination. That is fissile material. And just as an observation, it applies to the nuclides and not to the material containing it. Now, as far as material not covered by hazardous materials regulations, if it's not in transportation, it's not addressed or not covered by HMR. So HMR only applies to those items that are going to be transported. It doesn't apply to medical or research in the case of live animals. So it doesn't apply to any of the implanted radioactive materials that we talked about or that you've learned about over the last few semesters. It does not apply to radioactive material that is an integral part of the means of transportation. Now, I don't have a really good example of that one, but if the material is part of the transport vehicle itself and it's radioactive, it's not counted in the transport in the HMR. And then the natural radioactivity from the ores, provided it doesn't exceed 10 times quantities in that particular rate. So that's an introduction really to the transportation regs, as well as the terms or terminology used. We'll pick up more terminology as we get into it and as it's needed to understand what it is we're talking about. Next week we'll pick up and start talking about packaging. And it's very specific when the regs talk about packaging, because that is one of the primary means of ensuring safe transport of radioactive material is the package, not necessarily the transport vehicle, although in some cases it is, but by and large it's packaging. And so it's really important that the packaging is understood as you will be the ones that will be packaging it up in accordance with whatever procedures and processes that are in place at the facility. So we'll pick that up and start talking about it next week. And hopefully by that time I will have a test graded. I think we have two that didn't make it. Any questions? All right. Have a great week.